In this video, we are going to look at some of the useful strategies to prove trigo identities. Now, what are trigo identities? Basically, an identity is something which is true for any value of x. So if I write down an identity in terms of x, the left-hand side and the right-hand side will be equivalent for any value of x. So for example, practice 1 on page 86. This identity that we see here means that the left-hand side will be always equals to 1. Okay, the left-hand side, the expression, will always be equivalent to 1 for any value of x. Unlike an equation, for example, if I give you an equation like this, now this is considered an equation, not an identity, because this statement is only true when, for example, x is 90 degrees. If I put in sine 80 degrees, the answer will not be 1, right? So it's only true for some values of x. So that's considered an equation. So what do we mean when we prove an identity? We are basically trying to show that the left-hand side and the right-hand side are going to be always the same. So how do we prove an identity? We can start from one side of the identity and rewrite it in a different form to make it look like the right-hand side. So basically, we need to show that both expressions are equivalent by rewriting them in a different form. So what are some strategies that we can use when we are proving an identity? So on page 86, you will see these general strategies that you can use. So the first strategy is actually to start with the more complicated side. So if you look at the practice 1, right, you can see that the left-hand side is definitely a lot more complicated. So I'll choose to start with this. Why we start with the more complicated side? Because it's easier to simplify things rather than to complicate things a bit more. For example, if I started with the 1, right, how can I rewrite the 1? Can I write it as 2 minus 1, 0 plus 1? So it wouldn't make sense to split it like that. Whereas if I start with the more complicated side, then I can think of how I can simplify it. Okay, so the first strategy is to start with the more complicated side. The second strategy will not be helpful for this question. We'll come back to it in other questions. The third strategy, I think is very, very important, is to basically rewrite tangent, cotangent, cosecant, and secant where necessary into the basic trigo ratios. Now I've written down these functions in terms of its reciprocal functions. So for example, we know that tangent is sine over cosine, cosecant is 1 over sine, secant is 1 over cosine. Cotangent is actually 1 over tangent, and because tangent is sine over cosine, this is basically cosine over sine. Now, if you see any of these 4 expressions in an identity, it's helpful to rewrite them in terms of sine and cosine. Why? Because sine and cosine are considered to be like the simplest form. And then when you're trying to simplify things, right, we don't want it to have too many different terms. So if everything is in terms of sine and cosine, it'll be easier for us to do the simplifying. Okay, then strategy 4 is anytime you see a squared expression, for example, secant square, cosecant square, cotangent square, or even your sine square, cosine square, and tangent square. If you see any of these expressions, then that should actually ring a bell that you can use the 3 trigo identities that you have learned. I've written out the 3 trigo identities here as well. Sine square plus cosine square gives you 1. 1 plus tangent square gives you secant square. 1 plus cotangent square gives you cosecant square. So any of these identities will also be helpful. Okay. After trying this, if you are still not able to get any progress, right, then you might need to sort of change your strategy a little. So proving identity, sometimes the very first thing that you try may not work, so you may need to attempt it 1 or 2 more times. Now, something else that I always find helpful is strategy 7. Strategy 7 is actually to factorize, expand, combine fraction, basically any method that you can use to rewrite an expression. So we have learned things like factorization and expansion. All these are actually different ways to write the same thing. So these are also strategies that you can use. Later on, you will see which of these strategies would be helpful. Now, let us look at practice 1. So for practice 1, as we said earlier, I would start from the left-hand side. So let me just rewrite the left hand side and then let's see how we can proceed. Now the thing about proving identities is you know that you are working towards something. So for example, I know that I'm working towards getting the answer 1 because the right hand side is equal to 1. So always keep what you're working towards in mind and do things that will help you to move towards that. Don't do things that may not help towards that. Okay, so for example, right, if I'm working towards the value 1. Okay, so firstly I see that there is a, sorry, I missed out that x here. Firstly, you see that there's a tangent square here and there's a cosecant square here. Remember, when you see squared terms, what you may want to apply is the identity. But that doesn't mean I'm going to change, for example, tangent square is secant square minus 1. Does it mean I'm going to change this to secant square minus 1? And at the same time, cosecant square is 1 plus cotangent square. So do I do that at the same time? So don't do too many things at the same time. Think through which move will be helpful. So for example, I'm going to keep the tangent square as it is. Cosecant square, I'm going to replace it with 1 plus cotangent square. Then I just copy down this minus 1. Can you see what I'm trying to do? I notice that this 1 and this minus 1 will become 0. And then I notice that cotangent is actually 1 over tangent. So can you see that this basically becomes 1 over tangent square. Tangent square times 1 over tangent square will of course become 1. So it's not about just applying all the identities at the same time. I was actually able to see that cosecant square can become 1 plus cotangent square. And which means I want to keep my tangent as it is because cotangent becomes 1 over tangent square. So I'm trying to write them in terms of the same expression. Okay, so with that we are done proving this identity. So we can show that it has become the right hand side and therefore the identity has been proven. So this is generally how you think when you are approaching a proving identity question. Okay, now let us look at practice 2. Okay, for practice 2, again, you can decide which side you want to start with. As I said just now, sine and cosine are considered like the simplest form of the Trigo expressions. Therefore, I think the left-hand side looks a little more complicated. So I'm going to start with the left-hand side. It doesn't mean you can't start with the right-hand side. It might still work for some questions, but it may be a bit more, it may not be so intuitive, okay, as compared to starting with the more complicated side. So let me start with left-hand side. And remember, I'm keeping in mind that this somehow should become sine A cosine A. So if that's the case, right, then I don't want to see expressions like tangent and cotangent in my answer. So I should replace this to become expressions in terms of sine and cosine. So I'm going to change tangent to sine over cosine, cotangent to cosine over sine. Okay, then you will notice that I end up with something that looks like a complicated fraction. Although the final answer, right, there is no fraction. My right hand side has no fraction. So what I want to do is to simplify this. In order to simplify it, I'm going to combine the two fractions in the denominator to a single fraction. Okay, so how do we do that? Currently, the denominator here is cosine and the denominator here is sine. So I'm going to make the denominators the same by multiplying sine A here and cosine A here. Which means my denominator now would be sine A cosine A. Then my numerator from here is sine square. And from here, I have cosine square. Okay, the reason why I combined this fraction is so that now I can rewrite it as, instead of 1 divided by this fraction, I can change it to 1 times the reciprocal of this fraction. Can you see that I'm actually flipping the fraction in the denominator? Originally, this was sine square plus cos square over sine A cosine A. I flipped that fraction. Okay, why? Because I changed the divide to a times. Then you would notice that the numerator, because you times A, right, nothing changes, so it's just the new, this is just the fraction itself, the numerator is actually exactly what we wanted on the right hand side. So your final answer should just become this. Then that leaves you to figure out, then what do we do with the sine square plus cosine square? Remember, when you see squared terms, you can always look for the identities, see whether something is helpful. And in this case, something is actually very helpful. Sine square plus cosine square is equal to 1. So that means the denominator is basically just 1, which means we have arrived at our answer. Alright, that's the beauty of proving trigo identity. The answer is always there. It's about how you maneuver yourself to move towards that answer.